The light around 3I Atlas bends in the wrong direction, not toward it, away from it. This singular contradiction forces a quiet crack through the foundations of optics. It violates the symmetry we expect from gravity. It moves against the oldest intuition in physics, and it whispers a darker question. What kind of object makes light retreat? In the cold vacuum of interplanetary space, we expect order. We expect photons to behave like obedient messengers from distant stars. Yet around 3I Atlas, they pivot outward, carving a thin halo of defiance. A distortion field without a mass source. A lensing pattern without a lens. This is not a trick of distance. This is not a software artifact. Light field mapping confirms the anomaly. Rays diverge where they should converge. A quiet violation. A soft fracture in natural law. One spike stands out, a tiny plume of reversed curvature. A place where reality folds the wrong way for just a moment. And behind that spike waits a question with teeth. Is this object bending light, or is the space around it refusing to obey? 3I Atlas entered the public record as a minor transient detection. A faint visitor tracked by survey telescopes scanning for comets and near-Earth hazards. It was an ordinary object with an ordinary signature. Dim, fast, forgettable. But its story shifted during the refinement phase. As astronomers plotted early astrometric data, they noticed that stars behind the object dimmed by the wrong amount. Not too much, not too little. Just wrong. When the European Space Agency reviewed the preliminary frames, analysts flagged a low-priority anomaly. A subtle deviation in photometric behavior. A shimmer around the edges of the object. They labeled it instrument noise. They archived it. They moved on. Only months later, during a routine calibration audit, a junior scientist reopened the file. She noticed that the background star field shifted in a peculiar manner. Not toward the object, but subtly outward. A faint radial expansion in the light distribution. She requested a deeper field reconstruction. More data was pulled. More frames were aligned. The result was not noise. It was a trend. Light was bending away from 3I Atlas. The committee hesitated. If true, it would challenge general relativity. If false, it would be an embarrassing calibration mistake. Institutional caution prevailed. A second review began. During this phase, new observations from independent ground stations arrived. Each showed the same widening halo. A distortion field inconsistent with mass and inconsistent with emptiness. This time, the anomaly could not be ignored. The European Space Agency approved a full analysis package. Teams reconstructed the light paths using high-fidelity starfield tracking. Cold algorithms traced the curvature of photons one by one. Each path bent in passive defiance of physics. The discovery spread quietly through internal channels. Not publicly. Not yet. The anomaly was too delicate, too easily misinterpreted, too capable of igniting speculation. Then came the second cold spike. A small region behind the object showed phase deviations that did not match the motion of 3I Atlas. Instead, the deviations remained fixed relative to the background, as if the object moved independently of its own distortion, as if the field was not tied to the body at all. At this moment, the narrative changed. 3I Atlas was no longer a minor object. It was a contradiction traveling through space. Why does light bend? Under ordinary circumstances, gravity dictates the curvature of spacetime. Light follows the geometry. It arcs toward massive bodies. This is the foundation of gravitational lensing. It is clean, predictable, unbreakable. Yet around 3I Atlas, none of these rules apply. No measurable mass signature has been detected. No dust envelope, no plasma halo, no thermal bloom. Nothing that could create a divergence pattern. Researchers turn to pure optics. What if the object generates a refractive phenomenon? What if photons pass through a medium that forces outward curvature? But spectroscopy kills this idea quickly. There is no trace of gas, no volatile layer, no optical density gradient. The object is naked, cold, clean, so teams pivoted to geometry. What if the anomaly is not in the light? What if the anomaly is in the space through which light travels? A localized metric distortion. But here we run into a wall. Metric distortions require energy, significant energy. More energy than an interstellar object can quietly carry. More energy than its trajectory suggests. This contradiction deepened when formal uncertainties were computed. The covariance drift of the photon paths increased as they approached the object, not because the measurements degraded, but because the underlying variance of the field itself expanded, a sign that the system is not stable, a sign that space is changing shape at microscales. A cold spike appears here. Phase-space modeling reveals that photons leaving the region near the object behave as if they passed through a negative curvature pocket, a pocket where geodesics diverge instead of converge. This kind of geometry has no natural analog in classical astrophysics. Scientists explored exotic possibilities. Could this be a remnant of a topological defect? A cosmic string fragment? A small region of false vacuum decay? These ideas carry immense theoretical weight. They also require energy densities far beyond what is observed. Another class of theories examines inertial reference frame anomalies. If the object carries an internal rotation or a hidden structural oscillation, it could induce frame dragging. But frame dragging bends light inward, not outward, and the magnitude required would spin 3I Atlas apart. No known material could withstand it. The next idea pointed toward electromagnetic influence. Could an intense field reverse curvature? Not in any known formulation. Electromagnetism can redirect photons through scattering or polarization, but it cannot create macroscopic divergence fields in vacuum. This theory dissolves quickly. The final mainstream explanation attempts to preserve sanity. It claims the object is surrounded by a shell of metamaterial-like properties, a medium with a negative refractive index, a material capable of bending light outward. But this requires structure, design, manufacture, and spectroscopy confirms nothing of the sort. 3I Atlas remains visually simple, a faint, rapidly moving object, tiny, cold, unadorned. Yet the light around it behaves like an engineered system, a quiet paradox wrapped around a silent stone. Several details intensify the mystery. First, the divergence field remains perfectly symmetrical. Natural phenomena rarely produce symmetry this clean. Chaos introduces noise. Dust clouds introduce gradients. Rotation introduces asymmetry. But around 3I Atlas, the distortion field is a perfect radial bloom, a lens that repels. Second, the field does not scale with distance as expected. Most gravitational or refractive effects weaken with radius, but this anomaly flattens. It maintains strength across a larger zone than models predict, a sign of unknown physics, a sign of a hidden mechanism. A cold dread spike enters here. When photons pass the object, their outward bend aligns with a narrow band of angular momentum predictions that belong to no known mass distribution. It is as if the object does not generate the field, it merely sits inside it. Third, the anomaly does not drift with the object. This should be impossible. If the field is tied to the body, it must move with it. Yet observations show that the distortion partially lags behind, as though the space remembers where the object was, as though geometry has inertia. This leads to a stranger paradox. The object moves cleanly. Its trajectory is ballistic, but the space in its wake remains bent. A faint signature of negative curvature trails it like a ghost. Not a plume, not a tail, more like a memory in space-time. Fourth, the anomaly appears only in optical wavelengths. Infrared shows minimal deviation, ultraviolet shows none. This spectrum-specific behavior is deeply unnatural. Gravity does not choose wavelengths. Geometry does not discriminate. Something else is happening. A second dread spike emerges. There is a narrow spectral line where the divergence intensifies. This line does not correspond to any known atomic transition. It appears only when background starlight intersects the field. It is not emitted by the object. It is extracted from passing photons. A signature without a source. A fingerprint without a finger. Fifth, the object does not tumble. Almost all small interstellar bodies rotate irregularly, but 3I Atlas holds a steady orientation with improbable stability. This stability is not absolute, but the variance is so small that it enters the realm of engineered behavior, or physical principles not yet known. Sixth, no radar return has ever been recorded. Not because the object absorbs energy, not because the object hides behind noise, but because radar waves return distorted in unpredictable angles, as if the outgoing pulse passes through a region of space that no longer respects linear propagation. Seventh, trajectory analysis reveals a mild but persistent deviation that cannot be explained by gravity from the sun. This non-gravitational acceleration is subtle, far less aggressive than what was seen in Oumuamua, but it is present, and it is consistent. And it aligns with the axis of maximum optical divergence. Each fact intensifies the paradox. 3I Atlas is simultaneously ordinary and disobedient. A small interstellar object carrying a contradiction, like a shadow. The anomaly forces physics to confront an uncomfortable possibility. Light may not always reveal mass. Curvature may not always indicate gravity. There may be regions of space where geometry behaves like an independent variable, a meta-law hidden beneath the equations we trust. 3I Atlas could be the first natural object to expose this deeper structure. Or it could be the first visitor wrapped in a phenomenon we do not yet have a name for. If space can push light away, even in small pockets, then our maps of the cosmos are incomplete. Every survey, every lensing event, every distance measurement becomes vulnerable to doubt. This object may be a seed of a new framework, a place where optics meet space-time in a forgotten corner of physics, a place where empty space gains agency, a place where geometry can repel. For now, the anomaly remains silent. 3I Atlas continues its path, unaware of the questions it leaves behind, unaware of the quiet tremor it sends through scientific thought. But one final cold spike waits. In the newest reconstruction frames, the divergence fields show signs of growth. Not dramatic, not dangerous, but measurable. A slow strengthening of the optical distortion, as if the field is evolving, as if the space around the object is learning to bend light in new ways. If this trend continues, then 3I Atlas is not just an object. It is a message written in geometry, a silent invitation to step into a deeper layer of reality. A darker layer where the rules we assume are not the rules that remain.